As illustrated in Figure 8, if a convex lens has focal length f centimeters, and if an object is placed at a distance p centimeters from the lens with p greater than f, then the distance q from the lens to the image is related to p and f by the following formula. If f is 5 centimeters, how close must the object be to the lens for the image to be more than 12 centimeters from the lens? So from the information given, we've got f is 5. So we could go through and fill that in. They're also saying here, how close must the object be to the lens? So the distance from the object to the lens is p. So they want to know about p. They're questioning p's distance. And then they want the image to be more than 12 centimeters from the lens. So the distance from the lens to the image is q. So they're talking about q there. So here they're saying more than 12 centimeters from the lens. They want q to be greater than 12, is what they are saying there. And they want us to find the p that will do that. So what we're going to do is fill in what we know. First thing I'm going to do is fill in 5 for f. So I've got 1 over p plus 1 over q is equal to 1 over 5. I don't want all these fractions, so what I'm going to do is get a least common denominator here. I'm going to multiply everything by 5pq on everything. As long as you do it to all terms on both sides, that keeps your equation balanced. So that cancels the p, I get 5q. This cancels the q, so I get plus 5p. This cancels the 5, so we get pq. So then from there, what I'm going to do is they told me a statement about q. So I want to get q by itself. I'm going to subtract 5q to the other side so that I'm getting all my q's on one side. So I have pq minus 5q. From there, I'm going to factor out the q that they have in common. Factor out the q. So that leaves me with p minus 5 if I take out the q. I'm then going to isolate the q by dividing by p minus 5 on both sides. Cancels your p minus 5 and gives you that q is equal to 5p over p minus 5. So then what we want to do is we want to bring in that inequality. So they said q, they want that to be greater than 12. Well, this is q. So we're going to set this greater than 12. We're going to set that greater than 12, and they want, remember, they're asking about p. They want to know p's distance, so we're going to solve for p. So from there, you're going to multiply the p minus 5 to both sides. That gives you 5p is greater than 12 times p minus 5. Distribute your 12. So we get 12p minus 60. Then I'm going to get my p variables on the same side. So I'm going to subtract 12p to the other side. That gives me negative 7. And then I'm going to divide by negative 7. That flips the inequality and gives you positive 67ths. So now we know that p has to be less than 67ths. So then from there, we want to think about what we know about p. So we know p has to be less than 67ths of a centimeter, but if we go back and look at the image, we see that p has to be larger than f. So f is that focal length. So p has to be greater than f, and they said f is 5. So we also know that p is greater than 5. So we know it's less than 67ths, but we also know p is greater than 5. So those two things combined would be 5 with an open endpoint, 67ths, open endpoint. So P has to fall between these values. So we would say in terms of a interval that x is in, or P, sorry, let's use the right variable. The distance from, and what was P again? It says P is the object's distance from the lens has to be between, or in the interval, 5 to 67ths. Between 5 and 67ths.